Hello everyone, this is your tutor Gus. With me here is a mathematics question from syllabus D from the year 2022, paper 2, question 6b. So the question is, find the equation of the normal to the curve y equals x to the 2 minus 3x minus 4 at the point 2, negative 6. So that is the question. So if they say find the equation of the normal to the curve, we know that to every curve there exists a tangent. Then to that tangent there exists a line that is perpendicular to it. So that line which is perpendicular to the tangent is the one we are calling the normal. So we will start by sketching the graph of the curve. So we are going to say, okay, we will sketch the graph of the curve. So we are just assuming this curve, since it is y equals x squared minus 3x minus 4. Since our a is positive, we know that we are going to have a minimum. So it will go downwards like that. Then we can just assume the tangent anywhere here. So that one, we're going to call it our tangent. Then to this tangent, there will be a line which is perpendicular to it, and that is the one we are calling the normal. So we can assume this is our curve, which is x to the 2 minus 3x minus 4. Then there will be a line perpendicular to this tangent, and that line is what we are calling the normal. So this is just some estimation. So that's what we have. So for us to find the equation of the normal, we are going to rely on the equation of a straight line, since we know that the normal is a straight line. So we are going to say y minus y1 equals m open brackets x minus x1. So where are these coming from? This is coming from the equation of a straight line, and the normal is also a straight line. So we'll get the point there, which is 2, negative 6. So 2, negative 6. And then we are going to name this one as x1, and we'll name this one as y1. Then from there, we are going to utilize what we call calculus to find the derivative of this curve. So we should bear in mind that at the point of intersection, the tangent and the curve have got the same gradient. So we are going to differentiate this curve. So we'll find dy dx, which is y has been given as x to the 2 minus 3x minus 4. We find dy dx. We have to drop the power, which is a 2, we drop it, and then to that existing power remove 1. Then if a number is attached to the variable x, just ignore the variable x and maintain the number. And then if the number is just alone, simply write a 0. So I go again. If there is a power, drop it. We drop the 2. We subtract 1 from the same power which was dropped. Then we write the variable. If a number is attached to a variable, simply just write the number as a derivative. But if you have got a number on its own, write a 0 as the derivative. So here we are going to have 2x Then 2 on top minus 1, we remain with 1. So we'll not write the power 1, we'll just leave it like that. Because whenever the letter or a number is just written on its own, it is always indicating that it is to the power 1. Then here we have got negative 3. So this is the dy dx, or the gradient of the curve. But let's just consider where they have given us a point. So they have given us this point to be 2, negative 6. So at that point, just consider the value of x and replace it there. So at this point of intersection between the tangent and the curve, the gradient is the same. So we are going to say dy dx, which we can refer to as m in this case, and replace the value of x, which is a 2 on x there, minus 3. Then we're going to have 4 minus 3 equals 1. So this is what we have as the gradient of the curve. This is what we have as the gradient of the curve. So the gradient of the curve at that point and that of the tangent are the same. The gradient of the curve and the tangent at that point, they are the same. So now there is an idea which we say, if the two lines are perpendicular to each other, then if you multiply their gradients, the answer is negative 1. If two lines are perpendicular to each other and you multiply their gradients, the answer is negative 1. Why am I saying that? This is because we have the tangent and we have this line which we are calling the normal. And we have identified that at this point of intersection between the tangent and the curve, the gradient is the same. Meaning we know that since the tangent is a straight line, the gradient is the same throughout the line. Hence, it is going to give us an idea to say, if we multiply the gradient of the tangent and that of the normal, the answer should be negative 1. So that's what we are going to do. So here I go. I'll say m1 will represent the gradient of the tangent times m2, which is the gradient of the normal. The answer will be negative 1. What is the gradient of the normal, of the tangent, which we are from finding? We found that the answer is 1. So we'll say 1 multiplied by m2. Whenever you multiply 1 with anything, the answer is anything. If so, you multiply 1 with 5, the answer is 5. In this case, we are saying 1 times m2. So the answer is m2. Then this side we've got negative 1. So this is the gradient of the normal. This is the gradient of the normal. Now our question asked us to find the equation of the normal. So the normal is simply a straight line. So we will rely on y minus y1 equals m, which we are going to name m2 in this case, then x minus x1. So from the point which we have been given, which is 2, negative 6, we are going to say this guy is x1 and this guy is y1. Then we are going to replace them in this equation. This is the equation of the normal or a straight line. So that's why we're going to replace these two values and the m2 value, which we found to be negative 1. So that's what we are going to do. So let me do the replacement. We're going to say y minus the value for y1 is negative 6. So I'll put a bracket and then put negative 6 inside. Then equals m2 is negative 1. I'll just say negative 1 like that in the bracket. Then we have got x minus x1, which is a 2. So I'll put a 2 there. At this point, I'll say y. I'll multiply the negative and the negative to get the positive. Then this number is outside. It should be expanded to this bracket. So negative times x, it will be negative x. Negative times negative, it will be positive. 1 times 2, it is 2. So normally the equation of a straight line can start with y equals something, or x and y can be on the same side, but in this case I'll just choose to bring x this side, so it will be y, then I bring the x this side, or I find the additive inverse of negative x, which is a positive x, so I'll add x this side. Then I'll bring the 6 this side, so there is already a 2, it has not crossed the equal sign, so I maintain it. This one, we find the additive inverse, which is negative 6, or we simply say 6 goes this side to find negative 6. At this point, we have y plus x equals negative 4. And this is the equation of the normal. So I'll just go through once more. We had this question, which is saying, find the equation of the normal to the curve y equals x to the 2 minus 3x minus 4 at the point 2, negative 6. So this question carried 3 marks from the 2022 paper. So what I'm trying to say is that when we have been asked to find the equation of the normal, we should bear in mind that the normal is simply a straight line, and it is always perpendicular to the tangent. So every curve has got a tangent. So we make use of the curve given to find the gradient. Then consider the value of x at that point to be replaced in the differentiated curve. Thereafter, replace the point for x, the coordinate for x in the differentiated equation, so that you find the gradient of the tangent. Now that you have found the gradient of the tangent, you are going to use the idea to say when the two lines are perpendicular, m1, m2 equals negative 1. After you have found that, you're going to make use of the gradient that you have from finding, which is m2, and the point which you are given. Then you name those points, the point in terms of coordinates x1 and y1. Then make use of this equation of a straight line, which says y minus y1 equals m2 or m, but in our case, since we are finding for the normal, so that we do not confuse things, we'll say m2 open brackets x minus x1. Then replace the coordinates of the point which you are given and the m2 which you have found. Thereafter, be careful if they are negatives to multiply correctly. So that's how this question was to be solved. Thank you very much. See you in my next video.